right, welcome back. I hope you had a good break. I was sipping on some coffee. I'm baking some bread right now, so it was a productive 15 minutes. I hope that you did the same. So, we last were talking about types of bias, open and closed questions, and things of the like. And now, I'd like to talk about different types of variables that we will be working with in this class. And in statistics in general. So, typically in statistics, there are two big types of variables. And then within that, we've got some smaller, kind of more specific types. But first, we'll start with the big stuff, and we'll start with what we've kind of been talking about, especially when it comes to surveys. We have this idea of, kind of quality of something, right? Happy, sad. Blue, yellow, green, whatever. Those are all qualities of something, right? So we have this idea of qualitative variables, right? And that's variables that we can put into discrete groups, okay? So oftentimes, and I'm going to be referring to it kind of from here on out as categorical, because it makes a little bit more sense, I think. You're putting things into categories, right? So that could be like sex, male, female, race. That could be like income bracket or tax bracket. You're kind of putting things into boxes, essentially. Okay? And then within these categorical variables, we can have two types, okay? Two types of categorical variables. We've got what are known as nominal, where the variable itself has no order. So that's like assigned sex, when you were born, date of birth, full name, whatever. It doesn't matter sort of what order you put them in. It doesn't, male, female does not matter, is no different than female, male, okay? On the opposite end, same coin, just different side, we've got the idea of ordinal. And kind of the root there is order. There's a natural order to it. So satisfaction rating is an example of that, where you on one end you've got very dissatisfied, and then as you go further away from that, that means that you're getting more satisfied with whatever. Education level, right? We do things in that order. We go from kindergarten to first grade up through 8th, and then high school, and then college, and then, whatever after that. Same thing with socioeconomic status as well, right? The order there matters. The order represents something, okay? All right. And then, moving on the other end, we have this idea of another Q. Instead of qualitative, it's quantitative. Quantitative. Kind of hard to spell. That is numbers. That's it. 1, 2, 3, 4, whatever, right? You can just read it here, but anything that is, not put into a group, anything that has a value to it, height, weight, those are all quantitative. Those all have values associated. Okay? Just like in qualitative variables, we also have kind of subsets or sort of descriptions of quantitative variables. Okay? So the first type of quantitative variable, the first type of number that we can have are known as discrete. And what does that mean? Well, that just means that it's a number that's been rounded. Okay, so it's a whole number, and it can't be divided into fractions or decimals or whatever, right? So it's a totally countable thing. Totally countable. You can actually count the number, right? And then on the opposite end, we have this idea of a continuous variable, okay? So that is, slightly different, but it kind of just falls onto a continuum. And that means that I can go from 1 to 2, and then every number in between, right? oftentimes, we do kind of round things off. We like to have things in a discrete way because that makes them more sense. But if you think about it, when we're measuring height, you might round things off to an inch, right? 5'11", 5'10", whatever. But we know that not everyone is the same height. I might be 5'11", and you might be 5'11", but if we were to, put heads up next to each other, there might be a small difference, right, that we just care not to record, right? If we were to, then we would have a bunch of different, 5'11.1, 5'11.4, 5'11.4, 5, 6, 7, whatever. When you put things onto the continuous, you can get very granular with it, right? Even though you might not need to, okay? The take home is that discrete variables, discrete numbers are whole numbers. And then continuous is anything with a decimal. And it goes off, into however far you want. Okay. We'll be doing a lot of graphing in this class. And so when we work with discrete values, oftentimes we put them on, this sort of number line, this x and y axis here, this plane, and represent each value with just a dot, right? Let me get a better color here. Just use this. Each value with a dot. But when we move over into the continuous world, oftentimes things kind of get clumped, or there's not a big difference between point A and point B. So we'll just draw a line through all of them, right? So there are, on here, there are a bunch of different points, but they're all clumped up together. So we just care to draw a line through them. Because it's, either way it's easy to understand, but there are some kind of conventions with that. Okay. Going back into the world of sort of measurements, okay? We'll talk more about different types of data when we're actually, different types of variables when we're actually doing some analysis, but for now, just an introductory kind of thing. But when you're looking in research and when you're trying to design a research study, there's a few things that you need to take into account. We've talked a lot about bias, right? Because it's very important and it's very easy to sort of have bias in making questions or making a survey or whatever that goes, kind of unseen. However, when we're doing more experimental things, bias shows up, but we also have this idea of validity and reliability. Okay, so the first one here, validity, just refers to the idea that the tool, whatever you're using, actually measures whatever you're trying to measure, right? So oftentimes when you're measuring like feet, you use what's called, feet, you use, when you're measuring height of a person, you use what's called a standiometer. Okay, that is the tool that everyone uses. That's the thing where you stand up next to it and stand up real straight and the thing falls on your head and it tells you how tall you are, right? That's the tool that everyone uses. If you come into a research study and say, okay, I've got 10 rulers that I'm going to use to measure height, well, that's not, it's still the same idea, but it's not totally valid to do when there's already a standard, right? Next, we have this idea of reliability, which just sort of refers to the idea that the tool that you're using is good. You can rely on the measurement of the tool, right? So I remember when I was in undergrad and working in a lab, in a human physiology lab, the standiometer, the thing that measures height, was in a really old building, and something happened. There was like a small earthquake or something, and the foundation of the building actually kind of shifted just a little bit. That means that we had to find a whole new building to put the standiometer in because it wasn't reliable anymore. we had to actually move it because it was giving slightly different readings every single time, right? Which is not what you wanted. Going away from like physiology and thinking about like, if you're a musician, tuners, when you're tuning your instrument, oftentimes run on like a battery. When the battery starts to die, the measurement that it's taking, right, the tune of whatever string or whatever sound you're making will become slightly inaccurate, right? It becomes less reliable as the battery ages, right? Just another example. And then lastly, good Lord, we've been talking about it forever. This idea of bias here, just prejudice in one direction, right? When you are surveying, right? That's a tool. A survey is a tool. Oftentimes those have some bias, but also tools like physical tools also have bias, right? They also have some bias that you just have to make sure that you address and kind of remedy in some way. All right. So a big thing in statistics is this idea of variability. We'll put that right here. Okay. Oftentimes, measurements are going to differ, no matter what, right? You ask somebody, how happy are you right now? They're going to give you a different answer if you were to ask them tomorrow or the day before, right? They're going to be not everyone is the same level of happiness every single day. Same thing goes with height, believe it or not. When you wake up in the morning, I think you're a little bit taller in the morning than you are at night. Same thing with weight, right? You wake up in the morning and you weigh less. You weigh probably the least you will throughout the day, but then as you eat and as you drink, you're going to be, gaining some weight throughout the day. Just a little bit, but enough to kind of spark some ideas and say, okay, we need to make sure that that's something that we control for. And there's many ways to go around that. But variability is something that statistics is kind of rooted in. Oftentimes in a lot of tests, statistical tests, we're measuring variability rather than, something else. The variability tells us a lot about what's going on, believe it or not. So going into that idea of variability and kind of the idea of like error almost, not totally the same thing, but close to the same thing. Sources of error, we have two big ones. The first one is like a measurement error. The battery in my tuner is dying, right? So that is going to have a slightly different measurement than it will if the battery was totally new, right? Same thing with the stadiometer in the building that had a shifted foundation, right? Not good, not cool. Scales, oftentimes, like bathroom scales are like way wrong a lot of the time. Sometimes it's because it's not calibrated. Tools in general need to be calibrated. If you work in a lab, you're probably familiar with that. It's something very important to do all the time to make sure that all of your measurements are consistent with each other. Then we also have this idea of natural variability, which is just bad luck. I like to use the example of a 5K. Okay, so a 5K run, 3 point whatever miles. If I were to run a 5K this week and another next week and another next week, I probably will not have the same time each week, right? Same goes for you too. Unless you're like a pro athlete, and even pro athletes, if you were to get down into the decimals, right, their times are going to be different day to day, week to week, right? Just because of natural variability. There's so many things that go on in the world that can affect so many different things, right? And that's something that everyone is susceptible to, and not totally invincible to. Okay. All right, so we've got the two big types of error. This is something, measurement error, can be prevented. Natural variability here cannot, right? It cannot be. Okay. And then that's pretty much that. This idea of measurement error and variability, very important to understand. Measurement error, just a source of variability because the tool that you used was not good, right? Not calibrated or broken or old or whatever. But then natural variability just happens, and it's just bad luck, you know? So trying to keep things consistent is sort of the big take home here. All right, so that is that for this one, and I will see ya in the next one.